Okay, in this problem, they tell us that we can model the height of a falling object with the equation h equals -16 times t squared plus v sub 0 times t plus h sub 0. And whenever they give you an equation like this, they'll follow up by telling you what some of these variables will represent. So v sub 0 is the initial velocity, right? So this is referring to basically the speed you have at the start of whatever situation you're looking at or whatever object you're modeling with here. T is our variable for time, and h sub 0 is the initial height, so how far up is the object before it begins to fall. And then I go back and I always look back at the function to reread it, and I might even rewrite it for myself so I know that h here, they're talking about height. -16, they haven't told us what that is, but that's times t squared or times squared plus, right now, I'll separate these terms in parentheses for myself, v sub 0, that's our velocity, times the time, plus h sub 0, so that's the initial height. They want to know, why is this function nonlinear? Now, in the question that I'm relating this to, it relates to a question that's multiple choice, and so I'll talk about this question in a sort of narrow fashion for a moment, then we'll expand it to a table and graph. So what they're looking for you to identify is that in this function, right, when you graph it, you will not get a straight line. In other words, something is nonlinear, right? This literally means non-straight, so maybe curved, right, or nonlinear. It could mean there's some curvature of some type, or it could mean or bent in some way, or anything, right, that does not have a constant rate of change. And that's, I think, one of the answers that you might be able to pick if you're looking at this on like a multiple choice or a standardized test. So anything that does not have a constant slope or rate of change, right? And I'm just writing this out. Okay. All right, so that being said, I mean, that's like the idea that if we have a graph right here, this is our x and y axis, any type of curvature, right, in any form would be nonlinear. Bent, I mean, that's my adjective right there. But what I mean there is maybe if we have a line and then it bends in some direction, or it's just not a constant rate. So linear, in contrast, right, if you look at a linear function, right, that would be a perfectly straight line. So here's some linear functions, right, one like this, or horizontal, not a vertical line because that wouldn't be a function. It would have more than one y value for each x value. So any non-vertical line. So as an example, go back here, this, right, is a vertical line, and that's not a function. So all these are not linear functions, right? There are other types of relationships, right? This curvature here is parabolic or quadratic. It's a parabola. And this line that's bent is piecewise. This vertical line is just a straight line with an undefined slope. But down here are some examples of linear functions. So how can you recognize that right away? Because you wouldn't, or you might not be given space to graph or even draw a table. Well, one quick way to identify if you're going to have a nonlinear or curved function is to look at your variable. So there are lots of letters here. What's our variable? Well, the variable here is the letter t, right, that we're going to focus on, because height is really a function of the time. The initial velocity is important, so is the initial height, and those are variables, but here they're not really affecting the way this equation is running for all cases. They're different in each case. Time is always the one variable that affects your height. Think about an object falling. How much time has passed? Yes, the weight matters. Yes, the initial height matters. But the amount of time that is passing is the universal variable that affects your height. And if that's confusing you, any equation in this form, right, the variable that's repeated here, you see t is the only variable. Oops, it's not coming out very nicely, but that's a t, right? And so is this. that variable is being repeated. That'll help you identify it. Anyway, the variable, right, if it has an exponent of 2 or larger, or really anything larger than 1, it's a nonlinear function. So you can quickly identify a nonlinear function by identifying the variable, then looking at the exponent. If the exponent is larger than 1, it's nonlinear. But why does this happen? Well, let's just, let's play with this equation. So if you have the time, you can actually plug this into a table. So t is the independent variable. That's the time. You plug in the time, and that leads to the height. So let me just scroll up for a second here so you can see. So I'm going to plug in different times into the expression negative 16t squared plus what? Well, v sub 0 could be anything. Let's just make it 1, right, to get a sense of this function. So 1t. And h sub 0 could be anything too. Let's just make it the initial height 1 as well to make this easy to work with. I guess I can pick anything there. There's nothing to indicate that I can't pick those values. And so I plug t into this expression, and what comes out is the height, right? That's what our equation is telling us. So if you're trying to test this out and you can't, you don't remember how to think about this and don't have time to graph, a table will help you identify what's happening. So if we plug in 0, 1, and 2, we should be able to see that this is non-linear. In other words, the amount that the height is decreasing by after each second will not be the same, right? So here we get t is 0. We get 0 plus 0, right, because negative 16 times t squared, or 0 squared, because here t is 0, 1 times 0 is 0, plus 1. So our height starts off at 1. 1 meter. Oops, write the number 1. Okay, plug in 1, we get negative 16 plus 1 plus 1, so negative 14. And now, even though the context of the height here, this is negative 14 is below our starting point and perhaps even below ground level, so maybe this doesn't make sense in terms of a physical problem. Maybe it does, I don't know. But here, we're just looking for the rate of change. So now you plug in 2, so we have negative 16 times 4, which is negative 64, right, plus 2 plus 1. And you'll see here, right, fix these ones, that's what? Negative 64 plus 2 is negative 62, plus 1 is negative 61. The difference between 1 and negative 14 is, that's a jump of 15. So here the decrease, it decreases by 15. So you can recognize, if they gave you this table, you can also recognize that this is nonlinear. Look at the slope. Because here, right, this is decreasing by a lot more, right? Think of 61 all the way to 14. How far is that? We'll subtract 10 from 61, that's 51. Subtract 4 more, that's 47. This is a decrease, right? Decrease by 47, which is not 15. If it was decreasing by 15 each time, right, that would be a linear function. But that's not what's happening here, so this is not a linear function. So you can plug values in to test it, but also let's look at a graph. Here set up, this is the parabola that they're showing you, and this equation right here is what they're giving you. I'm plugging in values for h sub 0, v sub 0, that's this number 0, and h sub 0, and on these sliders over here I can play with that. So I can, if I change the height, watch this point right here as the starting height, right? As I raise it, the object starts at a higher or lower point. As I change the velocity, right, it can even gain a little bit of height over time due to the velocity it has, right? So here you can actually play with the function, but you can see the shape of the graph isn't straight, it's curved. So this is a nonlinear function, so you could graph this as well. Alright, thanks.